Hi everyone, we are S120 Part 1 students who are taking PHY110 are going to present our findings for Experiment 4 and Experiment 5. Over here, we have our group members consists of 5 people, starting from the left-hand side, which is me, Joshua Johnny, followed by Muhammad Aziz Ikman bin Muhammad Osman. And over here, we also have Enricis Janamail. And over here, we also have Max Pires Anak Vincent. And on the right-hand side, last but not least, Muhammad Isni Huzairi. Moving on to the next slide, we have the introduction for both of the experiment. For experiment 4, linear motion. Linear motion, also known as rectilinear motion, refers to the movement of an object along a straight path. It is one of the most fundamental concepts in classical mechanics and forms the basis for understanding more complex physical phenomena. In linear motion, the object's displacement, velocity, and acceleration are confined to a single dimension, and the analysis typically involves key kinematic equations derived from Newton's law of motion. And as for experiment 5, Hooke's law, in the field of classical mechanics, the study of elasticity plays a pivotal role in understanding how materials respond to external forces. One of the fundamental principles governing this area is Hooke's law, which describes the linear relationship between the force applied to a spring and resulting extension or compression, provided the material remains within its elastic limit. This law was first stated by the British physicist Robert Hooke in 1678, encapsulated in the formula of F equals to negative kx, where F is the force exerted by the spring, k is the constant, and x is the displacement from the equilibrium position. Moving on to the next one, we have the objectives for both of this experiment. For experiment 4, linear motion, the first objective is to investigate the relationship between force, mass, and acceleration. And the second objective for this experiment is to determine the acceleration of an object under a varying force. And as for experiment 5, Hooke's law, it only has one objective, which is to verify the accuracy of Hooke's law. Moving on to the next one also, we have the apparatus used in both of the experiment. In experiment 4, we have air track rail, blower, pressure tube, gliders, flags, photo gates, masses, mass hangers, string, and last but not least, spooling. Over here, we have a simple diagram which represents the whole experiment picture, but we clearly don't have it, so we take it randomly from an internet to represent the diagram for this experiment. And as the apparatus for experiment 5, we have helical steel with supporting stand and scale. And the second one is set of slotted weights with hanger, weight balance. So over here we have the image for this experiment. The tall one, we could call it a record stand, and the small plate is named weighting plate. Yes. And the rest of the presentation will be handed next to my team members who are going to present their part. Thank you.
Next, I will continue to the procedure experiment 4. Step 1. Assemble the linear air track set. Step 2. The pump was switched on and the air was allowed to blow through the track for several minutes. The track was balanced by adjusting the screws on the legs of the track so that the glider stays stationary and did not glide to either end when released. Step 3. One hook was inserted at one end and a flag was placed on top of the glider. Step 4. The mass of the glider and mass of the hanger was measured and recorded. Then, the length of the flag was measured. Step 5. One end of the string was attached to the hanger and the other end was attached to the glider. Step 6. Mass with a mass of 20 grams were placed on the hanger and 80 were placed on the glider. The string was placed over the pulley. Step 7. The glider was positioned exactly before the photo gate. The glider was released and the time shown on the photo gate was recorded. Note: in order to avoid mass from crashing to the floor and scattering, the glider was caught with a hand before the hanger reached the floor. Step 8. The procedure was repeated 2 more times to obtain the time average values. Now, we move to the step 9. Then, the slowed mass on the glider was decreased by transferring a mass of 20 grams onto the hanger. Steps number 7 and 8 were repeated. Step 10. The procedure was repeated 3 more times with 20 grams from the slowed mass on the glider added to the hanger. This is the video of experiment 4 was conducted. Now, we move to the procedure experiment 5. Step 1. The mass of the hanger was measured and recorded. Hanger. Step 2. The weight of the hanger was calculated and recorded as W in the table. Step 3. The scale was adjusted so that the pointer on the hanger was near the upper end of the scale when the hanger was unloaded. The position was recorded as X0. Step 4. The hanger was loaded with a 10-gram mass. The scale reading X1 was recorded. The load was increased by suitable increments to obtain 8 data points before the lower end of the scale was reached. All data W and X1 were recorded. Now, step 5. The process was reversed by unloading the same loads as in step 3. New scale readings X1 for each load were recorded. Step 6. The extension of the spring was calculated. Step 7. The extension force acting on the spring F for each total was determined. Here is the picture of the experiment 5 where it was conducted.
Okay, this is my part about theory experiment 4. This is about Newton's second law. Okay, on this experiment, the time taken by object to complete its journey is decreased when the mass H on the object also increase. In other words, relation between mass and acceleration are inversely proportional. This is show that linear relationship between mass and acceleration are support Newton's second law. If we see on that formula, F equals to ma. So what we do now, acceleration, we need to leave it alone on the right side. So if we bring the mass on other side, that will be equals to F over m. So we know that acceleration are inversely proportional to mass. So on this experiment, we get the same result. But if we referring to F referring to force act on the object, m is a mass of an object, and a is acceleration when the object is moving. When the mass greater and flex slightly decrease, the time taken of the glider and the flex to reaching the photo gate also getting decreased. Relation between mass and time taken are directly proportional following the formula F equals to m in bracket v minus u over t. So if we bring the t on the left side and we bring the f on the right side, so that will be t equals to m in bracket v minus u equals to m equals to force. So this is show that time taken on the object is getting decreased when the mass on the object is decreased. So That's it, our experiment now. So in referring by V is final velocity, use is initial velocity, and T referring to time taken. Therefore, on this experiment, proof result that acceleration of an object increase when the mass attached to it decrease, supporting Newton's second law of motion. It is F equals to ma. Theory experiment 5. We know that experiment 5 is experiment about spring. Okay, we know that spring is more relatable to Hooke's law. So what is Hooke's law? Hooke's law in mechanics, Hooke's law is approximation of the response of the elastic body. Based on the experiment result, the extension of the spring increase directly proportional to the force acted on the spring. This confirms that the springs obeys Hooke's law on its elastic limit. The relationship can be written in formula F equals to negative kx. So if we rearrange the formula to leave it the x alone, so we can get here x equals to F over negative k. By referring F is force that acting on the spring, k is spring constant, x is extension of the spring. So by referring that, so we know if the force acting on the object is increased, so the extension of the spring also getting increased. So the result must be directly proportional. Okay, so after that, why the negative sign on the k? Why so negative sign on the k is it mean the direction of the springs are go down. So what is that mean? The negative sign needs to be put on the constant spring. Okay, from the graph we obtain force against extension, F against x. A straight line passing through the origin was obtained, indicating the result is directly proportional. So on the result we get, on the graph we get, so our graph are getting a line like this. So that means our result are directly proportional, because if the force are getting increased and the extension also are getting increased, so where the gradient of the graph can be determined a constant, okay, and successfully prove that the Hooke's law. So from based on our graph are get directly proportional, so we can we know that our graph are prove the Hooke's law. Thank you.
So here the analysis for experiment 4. Number 1, the graph tells us that it illustrates a linear relationship between two variables, with the y-axis labeled as fn and the x-axis representing an independent variable. So the plotted points form a straight line with a negative slope, this indicating an inverse relationship where decrease as the x-axis value increase. Next, number 2, the gradient m of the graph is 3.158 times 10 power of negative 3 Nm per second. Next, the uncertainties gradient we get from the graph is 3.16 plus minus 0.06 times 10 power of negative 3 kilogram meter per second. Number 4, the relationship between the gradient m from the graph and the total mass mt equals to mt1 plus mt2 is the gradient of the graph represents the total mass of the system. Number 5, the percent error in this experimental value is 19.33%. 7. One of the factors that contribute to the errors in our experiment is the friction of air resistance could slightly alter the actual values. And then second, the vibration or instability in the setup might affect the measurement. Number 8, to overcome the factors as I mentioned just now is first, the accuracy of measurement need to be improved, such as take multiply reading for each measurement and use the average to reduce random errors. Next, the external influences need to be minimized also. We go through for our analysis for experiment 5. Gradient of the graph that represent is 41.35 Newton meter. And then number 2, work done in stretching the spring through 0.2 meter is 0.8266 joule. Number 3, the energy stored is equal to work done. So the energy stored there is 0.8266 joule. And then number 4, first error is inaccurate measuring tools. Second, not allowing the spring to come to rest before taking measurement. And then third, parallax error when reading the scale. And then number 5, the relationship is directly proportional, which means as the force increase, the extension will increases proportionally. So our discussion for experiment 4 is in this experiment demonstrate the relationship between force, mass and acceleration explained by Newton's second law, which is F equal to ma. By varying the mass, m2 change in acceleration are observed increasing, m2 result is higher acceleration. It's confirming that a larger net force causes faster motion. Conversely, increasing the total system mass reduces acceleration, highlighting the inverse relationship between mass and acceleration. Overall, the result validate Newton's second law and provide a clear understanding of how force and mass influence acceleration in linear motion. In this experiment also offer practical insight into real-life application of these principles, such as the motion of objects under varying forces. Next, our discussion for experiment 5 is the primary objective of our experiment was to verify by Hooke's law, which states that the extension of a spring is directly proportional to the force applied to it, provided the elastic limit is not exceed. The experiment involved gradually loading a helical steel spring with a slotted wake and measuring its extension, so both while increasing and decreasing the loads. So from the plotted graph, F versus extension, the resulting trend was a straight line passing to the origin. This confirming the linear relationship predicted by Hooke's law. So this indicates the spring obey Hooke's law within the range of applied forces used in this experiment.
This is the conclusion for experiment 4. The experiment was to investigate the relationship between force, mass, and acceleration. From the data, force increased from 0.2 to 0.8, while acceleration increased from 65.33 to 257.89. This shows that force is directly proportional to acceleration. The experiment also to determine the acceleration of an object under varying forces, based on the data, shows that the acceleration of an object will increase if the force increases. This shows that Newton's second law has been fulfilled. And this is the conclusion for experiment 5. The experiment successfully verified the accuracies of Hooke's law. The result shows that the relationship between extension force and extensions of the spring is linear. Based on data obtained, the force is directly proportional to the extension of the spring. When the material is stretched, the atom and the molecules deform until force is applied and When the force is applied, the material will return to original state where F equals to Kx.